Up till now, we've covered various properties of straight lines and triangles, including bisectors, perpendicular bisectors, altitudes, and points of intersections of lines. What we're going to do is draw all of that together now and look at an example of how these properties can link together and how we might calculate them. So let's set up the scenario. I've got a triangle here, QRP, and I know that RT is a line within the triangle in QS as well. What I'm also going to tell you is the coordinates. So I'm going to tell you that P has a coordinate at 8, 3, Q has a coordinate at -1, 6, and R is located at 2, -3. Now this here is a typical scenario we get in a question, and these are typical parts we'd be asked to calculate. So what this question wants me to do is first calculate the equation of the altitude QS within the triangle. Second, calculate the equation of the median, R to T, and then what is the coordinates of M? So M, if you look at the scenario, is a point of intersection of those two lines. So it's going to bring in together these three key things that we've been looking at for the last couple of videos. So let's break it down and do it step by step. So the first one, part A, was it wanted me to find the equation of the altitude Q to S. So in order to do this, I have to remember the fact that QS, being an altitude, is perpendicular to the line PR within the triangle. So the first thing we did when we calculated an altitude was we sketched it, so that was from the diagram previously. The second thing we then did was calculate the gradient of the line that it intersected with. So in this case, I'm looking for the gradient M of the line P to R. Once I've calculated that, I use the property M1 times M2 equals -1 to get my gradient of my QS, and then calculate the equation using the coordinate of the point Q. So let's break it down and do it. So gradient of P to R is given by 3 take away -3 over 8 take away 2. That's using the coordinates of P and using the coordinates of R. 3 minus -3 gives me 6. 8 take away 2 gives me 6. I get 6 over 6, which is 1. I then use the fact that I've got M1 times M2 equals -1 for perpendicular lines. I'm going to take MPR and make it my M1. So I'm going to say I've got 1 times M2, which is the gradient of my perpendicular line, i.e. my altitude. And I know that's equal to -1. So from that, I can tell you that the gradient of my altitude M2 is equal to -1. So I can use this, and I can use the coordinate of Q, which if I remember, if we remind ourselves, is -1, 6, and then substitute it in to create the equation. So I know I've got y minus b equals mx minus a, so in this case I've got y minus 6 equals m, -1, bracket x minus a, which is minus 1, so it's x plus 1. Multiply it out and we get a form of our equation of our line. So again, in this case, we would end up with y equals -x minus 1 plus 6 plus 5, or again, we could write it as y plus x minus 5 equals 0. So there you go. There's the first part. That's the equation of our altitude, QS. Second part that it wanted, so for part B, it wanted the equation of the bisector of the line PQ. So the first thing we had to do after sketch was find the midpoint of PQ. So I'd use my two coordinates of P and Q to do this. So let's call the midpoint the point T. I know that's going to be located at the average of the x's, so 8 minus 1 over 2, and the average of the y's, 3 plus 6 over 2. So in this case, I end up with 7 over 2, 9 over 2. Now, we've never said anything against having fractions or decimals within our coordinates, so this is perfectly acceptable to have this. What we then do is we have to find the gradient of our line. So we have to find the gradient of R to T. Remember, we can't use the perpendicular property, so M1 times M2 equals -1, because the bisector doesn't cut it at a right angle. It's not a perpendicular bisector, it's just a bisector. So, using that and getting the gradient of R to T, we get 9 over 2 take away -3 over 7 over 2 take away 2. What that ends up giving me, 9 over 2 take away -3 gives me 15 over 2. 7 over 2 take away 2 gives me 3 over 2. So 15 over 2 divided by 3 over 2 ends up giving you 5. So I know the gradient of my line then is given by 5. So our gradient is given by 5. We know the point R, which is on the line. The coordinate of R is given by 2, -3. I do also have the point here at T, but that would be slightly more complex to put into my equation than R. Always try and pick the easier of the two. And then I use the y minus b equals mx minus a to get the equation of my line. So y minus b gives me y minus -3, so it's y plus 3, equals m, which is 5, bracket x minus a, which is x minus 2. Multiply it all out and get it in the form. So I then end up with y equals 5x minus 10, and I've got a plus d here which goes over there, minus 13. Or, again, you can write it in the other form, y minus 5x plus 13 equals 0. So I've now got the two equations of my line. What I now want to do is find m. And m was the point of intersection. Now remember, we've got three different techniques we can use. We can use elimination, we can use substitution, or we can use equating. The way I've written the two equations, so x plus y minus 5 equals 0, and 5x minus y minus 13 equals 0, it's easier to actually use elimination. Treat them like simultaneous equations and add the bottom and the top together. That will eliminate the y variable. Then I just solve it for x. So I've got x plus 5x gives me 6x. Y plus negative y is y minus y, which is nothing. Negative 5 plus negative 13 is negative 5. Take away 13 minus 18 gives me 0. So from this, I can then say 6x is equal to 18. X equals 3. Take this value for x and substitute it back into here, and you'll be able to find y. Pick the easier of the two again, which would be the top. So I then know that 3 plus y minus 5 equals 0. So y minus 2 is equal to 0. Y equals 2. And again, we've got the x and the y part, great. We have to then put it back into the context. And in this case, we know they meet at the coordinate for the point M, which is given by 3, 2. So that's using all the different properties and all the different techniques that we've covered up to this point for bisectors, altitudes, perpendicular bisectors, and intersection of two lines. It shows how they can all be brought together. Remember these types of steps. This is going to be very important when it comes to sitting exams.